Hi everyone, I'm Inigo San Jose. I'm a technical solutions engineer at Google, and I'm very, very happy to be here with you kicking off Beam Day. And of course, I'm going to be talking about Apache Beam, which I hope is not a surprise for any of you. And the agenda for today is we're going to start talking about Apache Beam, what it is, and what is its model, what's the business proposition that it has, and we're going to end with one demo. So let's start with what's Apache Beam. So Apache Beam is an open source data parallel processing model that works both with batch and streaming, and it can be used in different distributed processing backends. And you might be asking, what's the difference between Apache Beam and other data parallel processing engines? So here it comes, the Apache Beam model. There are three main things that make Apache Beam different. The first one is that it's unified. We have a single programming model for both batch and streaming. It's portable, so it can be executed in different execution environments, and it's extensible. So we can provide and share new SDKs, IO connectors, and transformation libraries. What do we exactly mean when we say that Apache Beam is unified? This means that for both batch and streaming, the SDK is the same. So if we write something in batch and we want to move it to streaming, we don't need to change the code. We only need to add some standard logic that comes from streaming because we need to use unbounded sources. This can be adding windows or splitting the bounded source in different chunks of bounded data. So an example of this could be if we have some batch pipeline that uses a map or uses a flat map, we don't really need to change anything from it to a streaming. The same exact code will work from one to the other. And the same with a group by. If we're adding a group by from batch to streaming, we only will need to add these windows that I mentioned before. Apache Beam is portable, so we have different SDKs, different languages that you can write your pipeline in, and you can run this pipeline in different runners. So for SDKs, we have Java, we have Python, Go, and SQL. And for runners, we have Cloud Data Flow, Flink, Spark, and we can even run it in our own computer via Direct Runner. And the advantage of this is that you can use the same pipeline that you wrote in Java, Python, or whatever SDK, and you can send it to different runners without changing pretty much anything from your code. So you only need to change the options that are used to reach this execution engine. For example, if you're using Cloud Data Flow, you need to add a project that is going to be the project in GCP that the pipeline is going to be running. But if you use Direct Runner, you don't need to change anything with these options. In this example, we have a sample key. You can see that the logic in Java, Python, and Go is pretty much the same. SQL is, of course, a little bit different, but this is expected. So I want to explain you how this flexibility came. And before doing that, I want to start explain a bit of the Apache Beam history. At the very beginning, there was only Java and some runners, and we needed a way to translate from Java to the other runners. So there was a specific way to translate from Java to Dataflow, another way from Java to Splink, another way from Java to Spark. And when new SDKs came, this approach wasn't the best, of course, because we will need a way from Java to Dataflow, another way from Python to Flink, another way from Python to Spark, and this doesn't scale. In case that we wanted to add a new SDK, we will need to create a lot of translations between the new SDK and all the runners that we have, and the same in case we wanted to add a new runner. So the Apache Beam team came up with this idea. So on the top, we have the SDKs, Java, Python, and Go, and in the middle, we have the runners. And in between those, we have something called the Runner API. This Runner API, what it does is translates from Java, from Python, or from Go to an abstraction of those languages, which we actually use protobuf, since it can be read from pretty much all the languages. And this abstraction gets sent to our runner, which they read this pipeline and actually know what they have to do. And between the runners and the pipeline execution, we also add one layer. This is the Fan API. This Fan API is also needed because we need a standard interface to connect from our code to our execution engine. And we didn't want to do this for every single language, for every single runner. Let me show you a bit how this works, what's the schema of all these. We have in red everything that is language specific, and in green everything that is language agnostic. So we have our Beam application in whatever SDK we want it, and this Beam application gets sent to the job server via the job API. Then this gets sent to our runner using the runner API. In this case, we're using Flink as an example, but of course, the same will apply for Dataflow or for Spark. Flink, our runner, gets different tasks assigned that it needs to execute. In this case, we have an executable state, a group by key, and another executable state. These executable stages connect to an SDK harness via the Fan API. These SDK harness are the pieces of the runner that actually execute the user code. And they tend to be Docker containers, but they don't actually have to be. They can be embedded within the runner itself, or they can be an extra process within the runner. And apart from the flexibility that using this Fan API and this runner API give us when it comes to adding new SDKs or adding new runners, it also provides one very nice feature. This feature is called cross-language. So let's say that we have our Beam application written in Python, and we want to use Kafka.io. Kafka.io is an IO that has been around in Java for a long time. It's very well tested, it's very mature, but it's not so much in Python. So instead of having to write the Kafka.io in Python again, we can use something called expansion service that connects these executable states with a Java harness with the Fan API. So we will be able to execute this part of the pipeline with a Java harness, and the rest of the pipeline can be executed with Python. We can see that after the first executable states with Kafka.io, we have another executable state, that goes to the Python SDK harness via the Fan API. And we can see that we have two steps there, Pardue and assign window. This is another optimization that happens with this Fan API. Instead of having to create one container for every single step, so one for Pardue and one for assign window, we only need one of those. We combine them together, we combine all the steps, and we only need this container. And finally, Apache Beam is very extensible. So we can create new SDKs and new runners. One example of those is SCO, which is an Scala SDK written by Spotify. And also is very customizable. So we can create custom sources and custom sinks in case that one of the IOs we need is not yet available in Apache Beam. Let's say that you need to reach an in-house database and we don't have any IO available there, you can create your own source and sinks. And in case you want, you can of course share it with the community. And also Apache Beam is highly customizable. We have a Pardue, which is a generalization of map and flat map that allows us to control the elements better, sending the elements to different P collections as we want. And there are other things that we can customize, for example, custom windows. With this, let's head off to the demo and see you there. So here we are in a JupyterLab notebook, which is the environment we're going to be using for this demo. And the idea of the demo is to show you how it is to change from one runner to another, and how it is to change from batch to streaming, just by adding this standard logic that we mentioned before, like adding windows or another way of splitting unbounded data into bounded data. The example we're going to be using is a word count, which is the hello world of the ETL pipelines. So let's get into it. Let me first import the things we're going to be using for the demo, and I'm also going to be importing some variables. These variables are going to be used to reach my project in Dataflow. So now we have the actual pipeline. And since we're going to be using the first example, interactive runner, we don't need to add any option the same way we don't need to add any options when using direct runner. Interactive runner is a specific runner made for notebooks that provides some extra visualization and is a good fit for this demo. So now it comes the actual business logic for our pipeline. We're going to be reading from a public bucket that contains a text file, which is the play by Shakespeare King Lear. So in order to read from this text file, we're going to be using read from text, and let's point to this path. Now, when we read from text using read from text, the output is going to be every line that the file contains, and we need to split that line into more than one word. So here it comes the actual word count. So let's do count source, and since we're outputting more than one element for input element, we need a flat map. So let's do now split words. Now, if you check the split word function, you can see that we're actually outputting key values. This is because we're going to be using a counter key later on. In this case, the key is going to be the actual word, and the value is going to be a 1. In reality, this value could be whatever, but for simplicity, let's use 1. And now we can do the count per key. Count per key. Now the pipeline hasn't run yet, since we need a specific way of running this pipeline. We're using Interactive Runner, and Interactive Runner provides us with a specific way of doing this, which is IVShow, and it gives us some extra visualization that you will see in some seconds. So if I do iv.show count, which is the variable we have here, we can see that the pipeline is running now, and in some seconds we will see the output of it. We can see that king appeared 243 times, and we can even see what was the word that appeared the most, which is the, not a surprise at all. So we have seen how to run a pipeline in Interactive Runner. Let's now move it to Dataflow. So we change the runner to Dataflow Runner. And we need to add these options that we mentioned before. So we first need a project. Project is a variable that is already imported here. We're going to need a region for the workers to be in. So let's use US Central 1. We are going to need a temporary location, which is going to be a bucket and a folder called temp. And I'm going to add a name to this pipeline, which is going to be, I don't know, word count bin day. So this is everything we need to reach Dataflow. And now we can see that the business logic remains the same. We don't need to change anything. And now we need to execute the pipeline. Before we were using IVShow, which again is something specific for Interactive Runner. So we need to modify this. So let's do pipeline equal p-run. P-run is the way of executing pipelines in Dataflow Runner or Direct Runner also. So if we do this, the pipeline should start reaching GCP. And if I run this next cell, it's going to help us see the link directly to GCP. So the pipeline is reaching GCP. And if I click here, we can see our pipeline running in our GCP project using Dataflow Runner. So you can see here that without changing our business logic, just by changing the options, we have reached Dataflow and the pipeline will work exactly the same. So let's see now how hard it is to change from batch to streaming. The first thing we need to do is to tell our options that we're using a streaming pipeline. So let's do streaming equal true. And I'm also going to be changing the name to streaming. Let's run this cell now. Now, before we were using a bounded source, which is a public bucket. Since our pipeline is streaming now, we need something unbounded. So let's use one PubSub topic. So let's do read from PubSub and our topic, which is again imported in this cell here. When we read from PubSub, the output it's on bytes, so we need to decode those. So let's do decode. This is the name of our step, and I'm going to be using a map function, lambda b decode UTF-8. PubSub is an unbounded source, and since we're going to be aggregating later with count, we need to split this unbounded source
into bounded pieces of data. In order to do that, we create one window that is going to split our data in chunks. So window into window dot, and I'm going to use a fixed window of, I don't know, 60 seconds. Yeah. So again, the pipeline hasn't run yet. We need to execute the next cells. So pipeline now should be reaching GCP, and in some seconds we will see the link that will take us to GCP. So now let's click here, and we're again going to GCP, and we will see our pipeline running in streaming. You can see it here, and the count is exactly the same. So you see that the only thing we needed to change was our source and adding this extra logic that we mentioned before, like a window, or in the case of PubSub, decoding the messages. But the actual word count, the actual part that we're counting, remains the same. So we didn't need to change the flat map. We didn't need to change the counter key. We only needed to change the source and adding this extra logic. So I hope you like this demo, and I hope you got the idea of the flexibility that Apache Beam has.
So thanks everyone. I hope you liked the presentation, and I hope you got an idea of the flexibility that Apache Beam has, and hope you like the rest of the Beam Day presentations. Thanks and bye.